Welcome to the third of our series of lectures on the history of the computer. This series is based on a documentary titled The Machine That Changed the World of 1992. It was written and directed by Nancy Lind and produced by the WGBH Television of Boston, Massachusetts and the British Broadcasting Corporation. Backers included the Association for Computing Machinery, the National Science Foundation, and the Unisys Corporation. We'll continue discussing the Giant Brains episode of this excellent documentary. In our previous two lectures, we discussed the early days of the mid-19th century with Mr. Charles Babbage, who built the difference engine and then designed his analytical engine, to Mr. Konrad Zuse in Germany in the late 1930s, who built the Z1, which later evolved into the Z2 and the Z3. Mr. Zuse built the first electronic computer as compared to Mr. Babbage's mechanical calculating devices. Mr. Zuse also used binary to represent data and did so with vacuum tubes, which manipulated electrons in order to represent those ones and zeros. In the early days of World War II, the United States Army commissioned the Moore School of Engineering at the University of Pennsylvania to build America's first electronic computer, because the human computers of the time were unable to keep up with the demand for firing tables. Those tables were needed in order to use that artillery and the other big guns that were being manufactured for the war effort. The two men in charge were J. Presper Eckert and John Mauchly, and the machine they built was called the Electronic Numerical Integrator and Computer, or ENIAC for short. Now we will continue in that general time period by discussing other pioneers in the field of computing. Meet Dr. Freddie Williams of the University of Manchester. One thing that is interesting to note is that Dr. Williams had the opportunity to meet Eckert and Mauchly and see the kind of work that they were doing at the time. Here is another website that reports that meeting. There's Mr. Williams. Here you see in 1946 he visited the Moore School of Engineering, home of the ENIAC, where research on cathode ray tubes was also underway. ENIAC was the first general-purpose electronic computer, but it did not have an effective electronic storage, and changing its program involved a painful process of reconfiguring the hardware, which could take days. So you see we have some supporting information about that video. However, during the war, Dr. Williams was participating in radar research in Great Britain, which itself was extremely important to the war effort. After the war, Dr. Williams returned to the University of Manchester, where he began working on computer research himself. He began designing the Manchester Mark I. I think we can assume that he was able to incorporate some of what he learned when he met Eckert and Mauchly into his research. But he did do one thing with his Mark I that Eckert and Mauchly did not do with the ENIAC. His Manchester Mark I was the first machine with storage. In other words, where the ENIAC had to be programmed at the time its task was being run and then reprogrammed to do anything else, Dr. Williams' Mark I could load a program, run it, then change the task. The administrator simply had to load a different program. Dr. Williams' Manchester Mark I marked a milestone in the evolution of the computer by introducing the first electronic computer that had storage. Our next pioneer in the evolution of the computer was Dr. Maurice Wilkes of the University of Cambridge, who you'll also get to hear in the Giant Brains episode. Interestingly enough, Dr. Williams was also reported to have looked at the work of Eckert and Mauchly when they were involved in research on the ENIAC. And here's another source on that issue. Here we see Dr. Wilkes. It says Professor Wilkes is best known as the designer and builder of the Edsac. And here we see in October of 1945, Wilkes returned to Cambridge to take full charge of what was now called the Mathematical Laboratory. In 1946, he was visited by Mr. Comrie, a pioneer in the mechanical computation, who brought with him a copy of the first draft of a report on the Edsac, written by John von Neumann, summarizing the deliberations of the group at the Moore School of Engineering, University of Pennsylvania. The Moore School of Engineering had just completed the ENIac, the world's first electronic computer for defense calculations. So there we have another source that we can consider. After the war, Dr. Wilkes built the Edsac computer, and here you see a couple of other images of Dr. Wilkes. The one on the right shows him with his Edsac computer. He's actually looking, I believe, at a storage device. And here we have one of the most fascinating characters in the history of the computer, Alan Turing. Dr. Turing, a mathematician, strongly believed that a computer could do more than just crunch numbers for mathematical problems. He introduced his Turing machine in a paper titled On Computable Numbers, published in 1936. And his papers on the subject are considered the foundation for research in artificial intelligence. Since we've been talking about the fathers of the computer, Alan Turing might be called the father of artificial intelligence. This lecture is being created in 2015, and there is a movie in the theaters right now on Alan Turing called The Imitation Game. It's a good and quite moving movie that you might want to see. During the war, however, Dr. Turing was involved in research for the British military at a research facility called Bletchley Park. He was involved in a cryptography project to try and decipher messages encrypted by the German Enigma machine. All messages sent by the Germans were encrypted using this machine, and the British had been trying to break that encryption. The Turing team designed a machine called the bomb, or Bomba, which in the Giant Brains video they call Colossus. Here's another source of information on this subject. This website, I believe, is the www.biography.com. And let me point out here that while we are visiting some external websites talking about the issues that we are discussing in this lecture, that does not mean that we should take everything we see on the internet as being necessarily accurate. But we try to look at a number of different sources and make our decision accordingly. Said he was born in 1912, and he wrote the paper in which he introduced the Turing machine. Further on down in here, it tells us about his experience in developing an electromagnetic device to help decipher the Enigma. There's Bomba, or Bombe, or Bomb. I'm not sure how you pronounce that. And there you go. It's an interesting discussion of Alan Turing. As I said, Dr. Turing was among the first to realize that a computer could do more than just calculate numbers. After the war, Dr. Turing built the ACE computer, and he is widely considered to be the father of computer science and artificial intelligence. And here's another external source, interestingly enough, by Dr. Maurice Wilkes regarding Alan Turing. Maurice on Alan Turing. Here Dr. Wilkes says, of course, Turing also had a great interest in whether machines could think. I was thrilled by the paper he wrote in Mind, Computing Machinery and Intelligence, which described the Turing test to measure the intelligence of computers. I have long felt that Turing would, if he had lived, have come back to this question, and I would have liked to have seen his views. A great deal has been written on artificial intelligence. Not all of it is nonsense. It could be that Turing, with his prestige, his great insight, and his wit, it is possible that had he lived, he might have restrained some of the excesses which you see in that area, but alas, he did not. Okay, apparently Dr. Wilkes was not all that convinced that there was any such thing as artificial intelligence, and he had differences with Turing on some of his computer issues, but on the whole, it sounds like another favorable comment about Alan Turing. All of the computers that we have discussed thus far have used vacuum tubes to represent those ones and zeros of binary code. The vacuum tube was a milestone in the evolution of the computer because, as we have already discussed, it increased the speed of calculation many times over what was capable with those early mechanical relay switches. But the vacuum tube did have its drawbacks. A computer used a great many of them. You may recall that the ENIac was supposed to have had something on the order of 18,000 of them. To complicate matters even more, they generated a lot of heat. 18,000 hot vacuum tubes in one machine just sounds like trouble. The next slide introduces us to one of the most significant inventions in the history of electronics, one that solved all of the problems of the vacuum tube, the transistor. In the late 1940s, these three men, John Bardeen, Walter Brattain, and William Shockley at Bell Labs, designed the first transistor, winning the Nobel Prize for their effort. The transistor is small and it generates no heat. It ushered in a deluge of new electronic products like the transistor radio, which one was able to carry around in a pocket or a purse. Its use in the computer greatly reduced the size and just as greatly improved the performance and reliability of the machine. So that completes this series of lectures on the early days of computing. Here are some of the topics that we discussed. It's only just beginning. Watch the Giant Brains episode of the Machine That Changed the World documentary, which you'll find below this video. I think you will find it interesting and entertaining. In the next set of lectures, we will be discussing material found in the second episode of that series, The Thinking Machine. There will be questions in both the coursework homework and the final exam on these lectures and the Giant Brains episode. See you when we start talking about the thinking machine of the machine that changed the world.